Hello. Let me introduce our next speaker, Alexey Golub.
Hi, everyone.
Alexey, are you ready for the new online format of your speech?
I hope so. There's only one way to find out.
Okay, so you have a great topic, GitHub Actions in Actions. Yep. I actually could read it. So good luck with your topic. And guys, you could ask any questions during presentation. And we will have 5 minutes after topic to discuss them. Or you could join the Zoom room after presentation and discuss it directly with Alexey. Yep. So let's start.
Okay. So hi everyone again. My name is Alexey, and today I wanted to talk about GitHub Actions, which is a relatively new project automation platform that has been released by GitHub. And I say relatively new because it has been out for a little bit less than a year. And although this talk was supposed to be given slightly earlier this year, it's still quite new. And I think a lot of people could benefit from sort of an introductory talk to this new piece of technology, which I think is pretty awesome. So let's get into it. But first, a few words about myself. So my name is Alexey, like I said a little bit earlier. I'm primarily an open source developer. I have been in software development for about 8 years now. In my free time, I sometimes speak at different conferences, such as this one, for example. And I also have a blog on my website where I write about different technologies that I think more people should know about, mostly some obscure or lesser known niche stuff that I think that are pretty cool. My primary stack in development is .NET, so I use C# and F#, and I also use JavaScript on the front end, of course. And the technologies I work with are usually cloud and web related or automation DevOps and stuff like that. So if by the end of the talk you'll find yourself that you have some questions, maybe it could happen that you don't have time to ask them during the QA session. You can always message me on Twitter. My contact is in the bottom right. So if you have any questions, you can message me. I'll be always happy to answer anything you have. So let's get into the presentation. So it makes sense to start talking about GitHub Actions by telling what it is at a glance, sort of high-level overview. And the first thing we can say about it is that it has been out for a little bit less than a year, like I said. So it has been globally available since November 13 last year. And previously it was in beta for around 2 years, but it was closed beta. And what globally available means is that if you're in any country or work in any project, you can access this piece of functionality in GitHub, and you can use it. There are no limitations whatsoever. As you know, GitHub usually releases new products in a limited fashion, so that are distributed across different countries first. And GitHub Actions is already globally available, so you can use it today. Besides that, it's also internally based on Azure pipelines. That in itself doesn't really matter too much, but if you have used Azure pipelines before, you will find GitHub Actions very familiar, pretty similar in many ways. And if you haven't, you can just discard this information on. Or maybe if you move to Azure pipelines in the future and you have used GitHub Actions before, then it will make it easier for you to do so. Besides that, of course, GitHub Actions has native integration with GitHub, which is quite obvious, I suppose, being a GitHub product. And that actually allows you to do really cool, interesting things with your repositories and your projects that we'll get into later. Of course, it uses YAML for configuration. As a matter of fact, it used HashiCorp configuration language while it was in closed beta, but it didn't really stick, so they changed it back to YAML after a while, to dismay of many people. But nevertheless, that's what we have. So GitHub Actions uses YAML for everything. And at the core of this platform is the idea of this modular architecture, which is community-driven. And what it means is that when you're building your automation workflows, like maybe your CI/CD pipelines or anything else that you may want to have in your projects, you're often just sourcing different parts, different building blocks from the community that have been written beforehand. And then GitHub Actions as a platform makes it really easy to do so. So community and like this open source sort of mentality is at the very core of this platform. From an infrastructural standpoint, it runs on all the major operating systems in the cloud, so Windows, Linux, Mac OS, and you can also self-host it, so you can run it on your own hardware if you want. That's also available with all of the payment tiers. You can also use it on a free tier, so you can run it on your own hardware if you have some, I guess, sensitive information or something like that. But otherwise, Windows, Linux, and Mac OS with different versions are available in the Cloud Runner. And like I briefly mentioned, it's also available with all account tiers. So whether you're free, pro, team, enterprise, cloud, or one, doesn't matter what kind of GitHub user you are. You can access GitHub Actions, and there are no limitations in terms of features. But there are some limitations in terms of how much of it you can use. And more specifically, since a lot of people are usually interested in this first of all, so how much do I have to pay for it? Is it even worth my trouble? And about that, there are basically two separations, or like a separation between two ways you can use it. So basically, if you have a public repository, your life is very simple, and GitHub Actions is free for you. So it doesn't matter what kind of account you have, a free account or maybe an enterprise account. If your repositories are public on the github.com, then you can use GitHub Actions for free without any limitations. However many projects you have, however much you want to use it, doesn't matter. While if you have a private repository or many private repositories, then some fees may apply. So first of all, depending on which type of account you have, you will have different storage quotas and also monthly minutes that you can use for free. And once you exceed those minutes, you also have to pay based on the operating system your runners are running on. So for example, with Linux, that one's the cheapest, but for example, if you're using Mac OS, that's gonna cost you 10 times as many minutes as it would on Linux. So basically, you have some quota that you have for free. So storage is for artifacts and stuff like that. Minutes is for how long your runner's been working on some workflows. And based off that, if you exceed that, you'll also have to pay as you go, depending on the operating system you're using. Okay, so let's get into what GitHub Actions actually is. So what it is in 2 words, or rather 4 words, is IFTTT for GitHub repositories. And IFTTT is a very catchy acronym that just stands for if this, then that. And it's sort of a catch-all phrase for, I guess, any system that has some events and also has a way to register to those events and trigger some actions or workflows based off of that. And GitHub is actually an example of that system. So in GitHub, we can have repositories, and repositories have things happening all the time. So for example, you have commits, right? You're working on something. You're gonna make some changes. You're gonna push them. Every commit that you push, or rather every time you push something, that's an event that's triggered inside of the GitHub ecosystem. Then whenever somebody creates an issue, for example, that's also another event. Whenever somebody makes a pull request, that's an event. Whenever someone makes a release, that's also an event. And there are a lot of different types of events in GitHub, so you can think of a lot of different examples. But the idea here is that for each of those events, you can sort of connect to it and set up a trigger that would run some actions based off of that event. So for example, for commits, we will have normally like CI builds. So whenever somebody pushes new commits, you will have a CI build running and checking whether it's valid. If you have somebody creating new issues, you might want to have a workflow that analyzes the content of that issue and labels those automatically. So for example, if it has a word bug in it or something like that, you can just label it as bug automatically. Maybe something like that for pull requests so that you can tag reviewers automatically. And for example, when you make a new release, you can just post a message on Slack via a webhook or something like that. So those are all events, and it makes sense to have some kind of integration based off of those events. And from a configurational standpoint, the way it looks is that you have a workflow. So a workflow in GitHub Actions is sort of like a top level, I guess, structure in configuration standpoint. And it's bound to some trigger. And trigger is one event or maybe multiple events. And there are some other types of trigger that we'll get into it later. But for example, we will have, let's imagine we will be running this workflow on every new push, or let's say pull request. And then whenever that happens, we want to run some CI workflow. So basically, we make a workflow that triggers on that event. And we'll set up jobs that do some build test coverage, stuff. And inside of those jobs, we will have steps. And the way it works, why this separation actually matters, is that workflows, they're bound to some triggers. So there's one workflow per trigger. And workflows are completely separate from each other. So they're running on entirely different virtual environments. Jobs also run on different virtual environments by default. So they run in parallel. But you can set them up to depend one on another. So you can have a job that only completes or runs after another job successfully completes. And then steps, of course, those are what jobs contain, and they are sequential, so each step goes after another, and then a step does not run if the previous step didn't complete successfully. And in case with jobs and workflows, the file system and the environment is not shared. In case with steps, they are shared, so whenever you make a change to the environment in the previous step, it will be visible from the next or the current step. So if you wanted to start using GitHub Actions today, it's pretty simple. You just go to your repository, click on the Actions tab, and then you can have this button called New Workflow. And just like that, it will offer you a bunch of starting templates. So for pretty much probably every technology, language, runtime in existence, you'll have a starting template. And here I'm using C#, so it offers me one for .NET Core. So I can click that, and it'll just give me a basic CI workflow. I have access to Marketplace here where I can see which actions are available. I can also click on documentation to see how I have to configure my workflows and stuff like that. So to start is actually fairly easy. You can just use the website to do that. And the way those workflows look, like I said, they are written in YAML, but more specifically, they, I guess, look like this. And let's just dive into this very simple workflow. So this one is a CI workflow, as evident by the name, and the name is at the very top. Although it's not required, I always like to put the name here because then I would be able to discern if I have multiple workflows running, which one it is. But what's important and what's required here is the on parameter, which is the actual trigger. So in this case, we want this workflow to run on push events and pull request events. So whenever somebody pushes new commits, or whenever somebody creates or updates a pull request. So then we define the jobs. Here I only have one job, which is called build. As you can see, the job section, it contains the build section. That's just the name I gave it. And then the important thing is that we have to specify which operating system, or rather more specifically, virtual image it has to run on. I just wanted to run on Windows, just for the sake of it. I don't really care which version, so I just say Windows latest. You can also specify a specific version. There are some, I don't remember which ones are available, but you can have a deterministic build that way. But I just don't care, so Windows latest will have to do. And then I define the steps. Here, they're a little bit down below. There are a few steps there, so let's go from the first one. The first thing we have to do in a CI workflow is, of course, get the code that we want to build and test. So to do that, we can have a checkout step, which uses the checkout action. And here again, I gave it a name. So I said name checkout. This is optional. You don't have to do that. But what's required is that there is a parameter called uses, and that specifies which action I want to use. And as you can see, it says action/checkout. What that actually means is that there is a repository on github.com, which is actions. So the organization owner name is actions, and then the repository itself is named checkout. So there is this pre-written, I guess, pre-configured step that I can use in my workflows, and that's already defined in this repository. But then also I put the @ sign and specify v2 because I want to use a specific version. And in this case, v2 is just a ref tag. So this is a git tag that that was pushed by the owner of this repository. And this way I can use this action from my workflows. And the actions organization is the GitHub Actions team, so they have some of the actions that are sort of ready for you to use. And then you can also use actions by other people. We'll get into that later. But here we're just going to check out the current commit, which it knows because it's in the environment variables, and then get that code in the current working directory. Then the next step is that I just need to install the SDK. So because I use .NET, I'm going to install .NET. Of course, it was something else like JavaScript. I would install Node.js. And again, in the Actions organization, they have a lot of those sections already, I guess, ready for you to use. So you would use setup Node if that's what you need. Here I'm just using setup.NET. And as you can see, it also takes some parameters. So in the with section, I specify the version of the SDK that I want to use. And then following after that, I just run some basic shell commands. So those are not actions, those are regular steps. So I just want to test and publish my project, so just generate the artifacts. And to do that, I can just use the .NET SDK, which has already been added to the path automatically by the previous step. So here I'm just using the default command shell because I haven't specified any other one. You can actually override that, and by default on Windows, of course, it's going to be the CMD shell. You can also use PowerShell, for example, that runs cross-platform, or you can use Bash if you're on Linux and stuff like that. So it's really up to you. But here I don't really care because they have some very simple command line arguments. And then finally, after I have those artifacts in a directory, I just want to upload them to the artifact section of my workflow. So whenever a workflow completes, you will see an artifact sort of section where you can download any files that you have uploaded. So here I just want to upload all of those things, and I just specify the directory that I built my artifacts and use the upload artifact action. And then once that's done, this is more or less how it would look. So I can go to Actions again and see my completed workflows. As you can see, there is one completed jobs. I can see the artifacts there. I can download them. I can also go to a specific job, log, and then look into how each of those steps have completed. I can see what kind of output it produced, whether the test were run successfully and whatnot. And then also it shows annotations and stuff like that. And what's pretty cool about GitHub Actions is that it has native integration with GitHub, as I briefly mentioned in the beginning. And one of those perks is that it automatically integrates in this checks system. So in GitHub, you have checks, which are basically just something that can run and see if the code that you're pushing is valid according to some rules that you have set up. And because this workflow has been configured so that it's triggered on pull requests, it automatically appears in the checks for this pull request. So I didn't have to specify anything or set up anything. It just happens automatically. So no extra work is required. And of course, it's successful. If it had failed, I would see a cross there, and it would tell me that this pull request should not be merged, and stuff like that. And additionally, it also has a feature that other platforms do not really have, is that you can use GitHub Actions Runner to report special structured logs back to the website. So here you can see that there are some warnings, and those warnings are actually produced by the compiler, but compiler still succeeded. But there are still warnings I can look at, and I can see that there is a no literal path to non-nullable reference type. I can see that it happened on this specific line 75, and I can see it in the diff view. So it's really useful. And the way it works is that there is a special format for output that you can use that GitHub Actions will be able to parse and then put it in the website in such a nice presentation. But here it works in a slightly different way. There is also another way which you can do that using matchers. So you can install custom matchers, which use regex normally, that look into the output of other tools, in this case the .NET SDK, and then based off of the format, they can also turn it and parse it in such a formatted way. Structured way. So that's pretty cool. And this is actually what setup.net did. So it's installed a custom matcher for the compiler so that every warning that it reports actually shows up in the diff view. So that's pretty cool. We also looked into, from the example, we've only seen the basic triggers, which are triggers based on the GitHub API events. There are many of those, so we only looked into push and pull request very briefly. But there is also, other, resources on GitHub that also generate events such as issues and releases and like projects and also all sorts of things. And there are around 20 of those. And additionally, for each of those events, you'll have sub-events in some cases. So there are actually a lot of things you can trigger on. But besides that, we also have the option to use a schedule-based trigger. In this case, it doesn't use any event. It just happens automatically every once in a while. So you can use cron syntax, for example, to have a workflow that runs, let's say, every 15 minutes or something like that. And also you can have manual triggers, which is pretty cool. So those are not something you can press with a button on the website. Instead, it's a URL that you have for every repository that you can send a post request to, and that will start a workflow if you have it configured. And that's pretty cool because you can have, for example, a Slack bot that you can say deploy to, and then it will send a post request here, and it will, I don't know, run some workflow that deploys a Docker image, the Docker Hub, for example. And what's also cool about it is that you can actually send custom payload, and you can parse the payload inside of your workflows. So that's really awesome. And the way those are configured are sort of similar to what we've seen already. So in the top left, we see an events-based trigger. So here it just triggers on push events. But here we also refine it. So we're not interested in all push events, but only on those that happen to branches master and release branches. So here you can see we can also use wildcards. So the asterisk stands for any input. So release v1 or release v2 will also be matched here, but not any other branch. So for example, dev branch will not trigger this workflow. And similarly, in the bottom right, you see issues, which is also an event. But here we also refine it so that we only trigger on issues, and the sub-events we're interested in are opened and labeled. So we don't really care about issues that have been closed or that had comments left up on them or stuff like that. We only care about open and label, for example. And then in the top right, we have schedule, which is just the cron syntax. In the bottom left, we have repository dispatch. So those are for manual dispatches. You can't refine on those, so you have to just type in repository dispatch. But then using different conditional expressions, you can actually do that inside of your steps, which we'll see in a little bit. Besides different types of triggers, we also have different ways to reference actions. And again, we've seen the first one, which is by GitHub repository. This one is the most common. And the way it works is basically you just specify the owner of the repository / the repository name, and then the ref tag. So the ref tag can be anything. It can be a tag, so like v1 or anything else that the owner of the repository pushed. It can also be a name of the branch, so master, if you want the latest commit on the master branch, or you can even specify hash of a particular commit. So basically everything that Git supports you can use here. And it doesn't have to be that an action is in a repository and there's only one repository to one action sort of link, but instead you can have a repository that contains many actions. And this is pretty common if you have an organization, maybe internally, and you have a lot of different actions. You don't want to have multiple repositories, you just put them into a single repository. And then you can use a relative path as well to specify which exact action you're interested in. So the format is the same, you just add / and then the path to the directory which contains the action. The other way you can reference actions is by file path. So actions don't have to be in separate repositories. You can have them in the same repository, which is also somewhat common if you have like many workflows in one repository that use the same action, but that action is not used across any other repository. So you can just put it in the same repository and reference using relative file path. And then also you can use Docker images. This is a little bit of a residue from the past, I would say, because this is not very common that you push Docker GitHub Actions as Docker images to Docker Hub. But if that's the case, you can use this Docker annotation to reference an image using its name and the tag. But most of the times you will use the first way of referencing, which is by GitHub repository, because that's what most actions are. Okay, let's get into a few of more advanced configurations or examples how you can use more advanced GitHub Actions features to give you some idea of, the capabilities of this platform. So the first thing that we're going to look at is the matrices. Matrices isn't very unique to GitHub Actions, so a lot of different platforms have it. And matrices allow you to make your jobs parameterized. So for example, if you have a job that you want to run using different environments or using different dependencies, but the entire job is pretty much the same except for different parameters, you can use matrices in order to parameterize them. And the way it works in GitHub Actions is actually pretty cool. You just specify your job like you normally do, but then you can also see there's the strategy section. We're just going to skip it for now, but take a moment to look at the runs on parameter, and then down below at the step section there is the node version parameter, and those use this expression syntax. So you don't just specify runs on Windows latest here, for example. You instead just reference the metrics. And same with steps, yeah, but when we install setup node, when we use setup node to install node, we specify the node version again through this expression syntax which references the metrics. And the metrics is actually configured in the strategy section. So here you can see max parallel that just specifies how many jobs you want to run in parallel. But then there is this metrics object, and every key in that object is just custom. So I just defined that as operating system OS and the node version. You can have anything you want there, and then you just specify arrays of available possible values that that variable can be. So in this case, I want the operating system to be either Ubuntu 16.04 or Ubuntu 18.04, and then node version is either 6, 8, or 10. So in result, I want to run my job. For example, maybe I have some very infrastructural specific component that I want to test on different operating systems and node versions. I can do that very easily by just creating metrics. And at the end of the day, we can reference some of that. And then at the end of the day, we'll have essentially 6 jobs. So for Ubuntu 16.04, we'll have node 6, 8, and 10, and then the same for Ubuntu 18.04. And those 6 jobs can be ran in parallel. So in this case, only 4 of them will be running in parallel, and then 2 of those will be waiting for the others to complete. But this is how you can do that. And then another thing you can use in your workflows is Docker containers. So you can, of course, just use the Docker CLI, but GitHub Actions offers a much more convenient way of setting up and running your containers inside of your workflows that will be available to anything inside of them. So what happens here is that, for example, we may have some, again, for simplicity's sake, some Node.js client that talks to Redis. Let's say we have some integration test that we want to run. And in order to have Redis running there, I could use the Docker image that is uploaded to Docker Hub. And to do that, I just specify the services section. I give a key Redis. This is, again, just custom, so I just need a way to reference it. So I call it Redis. And then I specify the image from the Docker registry. In this case, it's also Redis. And then, of course, since we want to bind the ports to something on the host machine, since we want to communicate with it, we can use the port binding. But an interesting thing here is that we're not just binding the ports on the container to something on the host, like specifically, but rather we just say, give me any port that is currently available that uses the TCP. And this way, it will just choose a random port that is available and bind that to the 6379 on the container. And then in our steps, when we actually use, you can also specify custom options to Docker create if you need to. But then in our steps, when we use when we want to reference this Redis container that we're running inside of our workflows, we can just use, again, this query syntax to get the job services, so the services section, and then reference the Redis service, and then get the port by looking at ports. And then, as you can see in the square brackets, we just specify the port on the container. So that will just return us the actual exposed port on the host machine that we can use. And for example, in this case, we're just passing it as an environment variable to our client. So this is just one example. Of course, you can have many services. You can have potentially complex setup if your workflows are very integration heavy. So this is something you can do as well. Another thing that GitHub Actions offers is the secrets feature. So oftentimes we have workflows that depend on some integrations with other services, and to do that, you usually have API keys. And of course, you don't want to expose them in your workflows that anybody can access. You can use secrets for that. And the way it works is whenever you need it inside of your workflows, so in this case, we have a step that collects coverage report and puts it using CodeCov CLI, puts it to their website. As you can see, I'm specifying a token here. I'm referencing, again, using the expression syntax, the secrets, and then I specify a CodeCov token. This is just something I've created beforehand. And the way I created is that I just went into settings. So I have a repository in GitHub. I click on settings and then go to secrets on the left. And then here you can just add any secrets that you want. You can create them, but once they're created, you cannot read them anymore, so you can just delete them if you want to edit them or something. So basically, this is a secure way of storing your sensitive tokens or keys that you may want to use in your workflows. And here I have got coverage token and some NuGet tokens, so I can use them in my workflows by just referencing the secrets object inside of them. And then additionally, of course, when all of that is running, we don't want the secrets exposed in the logs. So GitHub Actions is smart enough about that to look for any occurrences in of your secrets in the log, and if it finds them, they're just obfuscated and replaced with asterisks. And this is pretty cool because you don't actually, it doesn't just replace those occurrences that happen when you specifically pass a secret. So if the CLI just randomly decides to write your token to the console, GitHub Actions is going to obfuscate that as well. So it just looks for any occurrence in the output, and hides that. And another cool thing about GitHub Actions is that those steps that you create, they don't only have inputs, as we've seen earlier. Using the width parameter, you can specify different inputs, but they also have outputs. And these outputs can be used to have this kind of action-to-action I/O. And let's look at a simple example here. So here I just have a workflow that I might be deploying some application to GitHub releases. And to do that, I have to create a release first. And then after I have created it, I have to upload the assets. And I might have multiple assets, or I might not want to upload any assets. That's why those things are separate. And for the first one, I can use just the actions create release action that was provided by the GitHub Actions team. And for the second, I can use the actions upload release asset. The problem here is that in order to upload the release asset, I have to know which URL I have to use. As you can see, it has this input upload URL. But I cannot know it myself because it's created as part of the workflow of the build. So in order to have this kind of pipeline where one action specifies inputs to another action, you can do that by giving an ID to one of the actions. An ID is not like name, so in case with ID, it has to be unique and it has to, I guess, not have spaces. So in this case, I just have create_release to give the ID to that step. And then once I have an ID, I can actually reference that step uniquely in my other step and use, again, the expression syntax to say that from the steps create release, get the outputs, which is the upload URL. It just so happens that this previous action has many outputs, and one of them is the upload URL, which you would use for the uploading assets. And to figure out which outputs they may have, you would use documentation, of course. Unfortunately, there is no helpful anti-license because it's just YAML. On the website, there are some hints here and there, but usually your documentation is your best friend in such cases. Okay, and the other thing, also using expression syntaxes, we can create conditional expressions. So let's say we have a step that we don't want to use or run every time. We only want to run it if a specific condition is met. So in this case, we, for example, have some workflow that stays the same for the most part, but if the event that triggered this workflow is push, and the ref tag that's of the current commit or whatever the push was doing starts with the ref tags v, then we also want to push that to the package registry. So in this case, this if parameter can be used to specify a conditional expression, and you can use that to basically specify whether you want to run the step in some circumstances or not. As you can see, GitHub, the object here is just one of the objects that are provided inside of this context, where you can access different information. So here we have event name, also ref, which is the ref tag, and there are a few other things you can get out of there as well. And of course, GitHub Actions also provides some helpful functions like starts with, so you can use different operations and strings and stuff like that. So those are also listed in the documentation that you can look at. Another awesome thing about GitHub Actions is that you don't have to run them, push every time to see if it works. You can actually run them locally. And that's possible due to a community project called ACT by its author Nexus. And the way it works is that it simulates the exact virtual environment that GitHub Actions uses itself. And you can specify the events that are triggered inside of this virtual environment. And then it will parse the workflows that you have configured in your repository and run them as if they were running on GitHub Actions in the cloud or whatever you have it. So this actually shortens the feedback loop because you can quickly run your workflows locally and see if they work. Okay, so just to summarize a little bit of this section, let's see what we've learned about GitHub Actions so far. So it should be pretty clear by now that GitHub Actions is not just a CI/CD platform, so it's something that enables a wide range of different things. For example, we can use it to run, build, and test on every commit like you would expect. We can publish Docker images whenever a Git tag is pushed. We can automatically label issues by content when it's created. We can run, for example, nightly end-to-end tests using schedule triggers. We can, for example, have another schedule triggered workflow that would check if some issues or pull requests have been open and without activity for too long and then close them automatically. We can, for example, have a workflow that checks the code that has been pushed and then formats it and then pushes again if there are any changes. So you can format code automatically like that. And of course, you can integrate with a bunch of different third-party services using either actions that already exist or just using custom shell commands and stuff like that. So the possibility here are pretty much endless. There are lots of things you can do, and yeah. And the reason why this all is possible, I would say, and why this is so cool is because GitHub Actions has the community at its core. So it's not like many other platforms that just provide you with a set of tools that you just can use and have to use because there are nothing else and no other kind of source for you to ask for extensions and other tools. But with GitHub Actions is different. It's because GitHub Actions as a team provides a few starter actions that you can use, but also there are a lot of other actions developed by the community. And it really encourages that because it's really easy to reference GitHub Actions that have been created by somebody else in your own workflows. It's very easy to find them using the marketplace and so on. And it really enables you to do a lot of cool things with this open source mindset. And some examples of that, for example, if you wanted to have a workflow that sends a message to your phone number whenever you have a deployment or maybe a test has failed, you can do that, for example, using one of the custom actions by Twilio Labs called Action SMS. And then you can specify here in one of your steps what is the phone number you want to receive the message on, and then what's the message, and of course the API key and secret, and then it will just send the message to you. There's literally nothing simpler than that if you want to do that. For example, you may want to do something else. You may want to use Sonar Cloud if you want to scan your repository for some technical debt or something else. You can, again, use the GitHub action that they have provided. So Sonar Cloud GitHub action, reference in one of your steps, and then put the token inside environment variables, and you're good to go. The other example is one of the actions that I use myself a lot. So it's very, very common in GitLab, for example, when you start working in the future, you create a new branch, and then you finish it at some point, and then you create a pull request, and then people start reviewing it. This GitHub action actually simplifies that workflow by automatically creating the pull request for any new branches that you create. So for example, here I set it up so that it looks for branches that start with features, and then it automatically creates a pull request against the master branch. So whenever you create the branch, the pull request is already there, so I don't have to worry about it. Then another one that I wanted to mention because it's really cool, it's actually one of the actions provided by the GitHub Actions team, and it's called github-script. And the way it works is that you can run any JavaScript inside of your steps. But more interestingly, it also provides some objects that you can use. Right? For example, here we have a step that references that action. We also specify the GitHub token, but then we specify the script. And as you can see, I'm using this GitHub object to create a new comment on an issue. And it's basically the GitHub object is a pre-configured, pre-authorized OctaKit client, so I can use that to send API requests. And then we also have, as you can see, context here, which is all the data associated with the current execution of this workflow. So this is a really nice way to create some ad hoc workflows or steps that might not be available. So you can use JavaScript to just write something directly inside of your steps, which I think is pretty cool as well. Of course, you can discover all of those and many other actions using the marketplace. So you would just go to the marketplace, click on actions, and as of this video, there were around 2,500 of those. It was recorded in, I think, February, but now there are a lot more. Of course, you can search for anything specific that you want to use. For example, here I may want to use Discord integration to send a message there. I can see there's the action for that. I can look at the documentation, learn how to use it, see some examples. And all of that is just powered by the community, so the marketplace just exposes sort of publicly the repositories that contain those actions, and you can use them. Of course, if there is something that you want to use that doesn't exist, you can just write it yourself, so you can create your own actions. And there are two ways to do that. So with the GitHub Actions, you have the JavaScript-based approach, where you write actions using JavaScript. The advantage to that is that it's supported by all runners, so it doesn't matter whether it's Windows, Linux, or macOS. They will have Node.js installed on those virtual environments, so you can use the JavaScript-based actions everywhere. Of course, you can only use JavaScript, so it could be an advantage, but also a disadvantage to some people. And more importantly, you can use some other languages that transpile to JavaScript, for example, TypeScript. But at the end of the day, inside of your repository, you will have to have the JavaScript file that contains that action. And this is important because even if you use TypeScript, you still have to transpile it before you commit your action to your repository. And as a requirement, you use a self-contained JS file as an entry point, as I briefly mentioned. And as another advantage, you have access to some built-in modules like Actions Core and Actions GitHub. So you can just reference them as if they were installed. And then they provide some extra functionality. So for example, Actions Core, you can use that to talk to the runner, to report some logs directly to the platform. Or you can use the GitHub module to talk to the GitHub API and stuff like that. And also, I mentioned self-contained, so if you want to use any other node modules, you have to sort of embed them into one file. Again, it's kind of cumbersome, but this is how it works right now. So you can't just have a package JSON or a project JSON and then have it sort of installed as part of whenever you reference the action. So it has to be already self-contained in one file. And at a minimum, you need two files. So you need the manifest, which is action.yaml, and also you need your actual JavaScript file. So the way it looks is that for the manifest, you have to specify some basic metadata. So here I specify name, the description. This will just show up in the marketplace if I decide to publish it there. But also I specify the inputs and the outputs. And here the inputs are the arguments that I can provide to my actions. So here I just have a simple action that greets people. So I have a who to greet parameter. It has a description required, true, and the default value. And also we have outputs. So as you've seen earlier, we can provide some outputs so that other actions can reference and get it. And we have to specify how it runs. So here it runs on Node.js, so Node version 12. And then we reference the index.js file that contains our code. And then this file looks somewhat like this. So as I mentioned earlier, you can reference the Node modules that are available straight away. You can get the inputs using the core modules or core get input. And then you can write anything to console, of course, that will show up in the output as well. And then you can set outputs also using core modules. And then you can use the GitHub context to get any kind of context that is relevant to your workflow here. And the other option is the Docker-based actions. So besides JavaScript-based actions, you can use Docker. The current limitation is that it's only supported by Linux-based runners, so you can't use it on Windows and Mac OS. At least for now, I think it is going to happen in the future. And you can, as an advantage, use any language or runtime, so you're not limited to just JavaScript. You can use .NET or Go or Ruby or anything else. But on the other hand, it typically runs a little bit slower. So here, as a minimum, you need a manifest file and Docker file, so kind of similar to JS. And then in the manifest, the only difference is that you specify in the run section using Docker, and then the image And then the inputs you specify as the command line arguments. So here I have the Docker file and some bash script as an example. As you can see, it sets the output using the special format, which it uses 2 columns in that set output. So I'm a little bit low in time, so I'll just briefly go through the special commands. So there are different outputs that you can, or different commands that you can execute. So these are just stuff you can log to the console, and then based off of that format, it does something special. So you can set outputs, set environment variables, add the path to the path environment variable. You can also report debug warning or errors using a specific line and column in a specific file, or you can also mask some sensitive data if you need. And if you want to publish your actions, you can just create a release, and that automatically adds it to Marketplace. So as you can see, I've added some action that I've created earlier to the Marketplace, and it just shows up there. So this is just the README file and stuff like that. So just summarize, GitHub Actions is an automation platform. It's not just CI/CD. We can use it to trigger in different API events inside of GitHub, but we can also use different triggers based on schedule or on-demand triggers, like manual ones. And then actions provide the building blocks which are sourced by the community to create more complex workflows and build on top of those. And then those can be written in JavaScript or using Docker. Everything is pretty simple to configure and to set up. And as I said earlier, it's free for all public repos, and it's pay-as-you-go for private repositories. Here are some links for those who are curious to learn a little bit more. I don't really have time to explain what those are, so you can just check them out in your free time. And thank you for your attention.
Thank you, Alexey, for that interesting topic. How it goes? You feel okay with that?
Yeah, I think it went pretty well. There's actually a lot of things you can talk about in terms of GitHub Actions. I just wanted to give like an introduction that covers as much as possible, but does not go into detail. I think it went pretty well.
Okay, and I think that it's a good opportunity for everyone interested in that topic to join Zoom room number 3 for question and answers directly with Alexey.
Yep.
It will be much easier than do that in text mode. Let's check if we have any questions right now. Yeah, and we have a question. Can I configure deploy to private cloud like Kubernetes on private network from GitLab Actions?
If it's on the private network, you would probably use a self-hosted runner, I suppose. So I haven't actually tried that myself, but I know it's possible. So I think what you're asking about, it should be possible as well.
Okay. We see that people are thankful because I think it's a really useful and interesting topic. So, guys, you have several minutes more to ask questions here or after that in Zoom. So, just a question not connected with your topic. So, do you think what is the main advantage of online format in comparison with offline?
It's it's hard to point out the advantages, really. I think to most people it might help that you don't really see all of the audience in front of you, so it's a little bit easier to focus on the presentation and just be less nervous, I suppose. Yeah, I think that's the main advantage. It also, like, I mean, there's some, I guess, technical issues that can happen when you're making a talk offline, and then there, you have to take someone else's place, a speaker who just finished, and then something doesn't work, and then it's sort of rushed. In an online format, usually you have more time because you don't have to, I guess, move the audience around and stuff like that. So there are some, like, I would say, technical advantages to that.
Yeah, schedule is the king here, actually. Okay, interesting stuff, Alexey. So,
Thanks.
Actually, no questions more. So, we'll see maybe in Zoom you will have more conversation with guys regarding that topic. So, thank you once more for your time. It's very precious for us. So see you next time in online or offline, any type.
In October, actually, at the GitHub Fest.
Great. So, okay, guys, and you have a lot of different activities from our partners. So next will be Sigma company. So stay tuned. Be with us.